Good morning to everyone. I think that we can start. I was waiting for a few more people, but I think that we can start anyway. We had 12 registrations, 9 people are attending right now. So if they wish to join later, they can join later. We will start. Before starting, please, I'm asking to everyone who is not speaking to mute their microphone so that we can have less noise in the background. Thank you very much. As you all know, this is a webinar on the collaborative, collaborative asset management. I think this is the wrong the wrong intro slide. I noticed that only now, but we are talking about the collaborative asset management, not business process management. So we are talking basically about FITMAN. FITMAN is a portal, is a web-based tool. It is an integrated platform for managing tangible and intangible assets. And this is targeted mainly at virtual factories because, as you will see, this is management of assets, virtualized assets is mainly an issue in the virtual factory domain. So we are talking about manufacturing, of course, manufacturing ecosystems. This tool is based on open standards and more specifically on OAuth2, so we are talking about ontologies, on linked USDL, on RDF2, the resource description framework. As I said, it is a web portal, and it also supports the federation of multiple platforms, again, because we are targeting virtual factories. So we are talking about distributed ecosystems, where several enterprises are participating in the same ecosystem. So let's have a look on assets, what we mean by assets in this context. Basically, the term assets is used to represent any item of economic value which is owned by an enterprise. And we have organized these assets from a logical point of view into very broad categories. Resources and capabilities, but we can also think of them as tangible and intangible assets, respectively. So, for example, resources are tangible, and we are talking about machinery, hardware, vehicles, buildings, physical people, employees, for example, of the enterprise, while capabilities are intangible. So we are talking about knowledge, competences, relationships, and so on. So both of them, of course, are used to achieve some goal in the enterprise or in the virtual enterprise. So in the virtual enterprise, they are leveraged in a collaborative way. It means that assets, they do belong to some specific enterprise, but they are used in the virtual enterprise, so they are put at work in a collaborative effort. Because virtual factories are collaborative environment where several enterprises join forces to reach some common objective. So in this case, these assets, once they are virtualized, must be traded as services in the ecosystem. This platform, FITMAN, is dedicated to this, to the management of assets as a service, we call them, so virtualized assets that are traded as services within the ecosystem. The platform by itself is not targeted at the technical, the IT user, but more to the business one. So we are using ontology concepts to model assets, but nevertheless, it is not required that the user has a very deep knowledge of ontologies, of the technologies that are behind the ontologies. Especially, I'm talking about tools because there are plenty of tools for managing ontologies on the market, but most of them, and I will show you an example of this, most of them are very difficult to master from the point of view of a non-technical user. So let's have a look at the features of FITMAN CAM. So with FITMAN CAM, we are able to define, first of all, a reference ontology so that we can build these virtualized assets from concepts that are formalized in all two terms. So more specifically, we use classes, named individuals, and properties. Of course, ontologies and more specifically the all2 language is much more than this, but we are only using a small subset of this kind of technologies, because basically we don't need them to achieve our objective, and they are in our way to provide a user-friendly tool. So we describe assets by means of the reference ontology, and we store these descriptions in an online repository. Then from there, we create a service layer by adding a linked USDL description. So I don't know if you are familiar with this technology. Universal Service Description Language is an open standard. It is proposed by a consortium which is led by SAP, as far as I know, and it's ontology based, but it is targeted very specifically at describing such things as availability pricing, terms and conditions of services. And once we have an asset as a service item, we can also compose more complex services by bundling together several simple assets in a composite service. Once we have defined our service, we can publish it on a store, which is part of a service marketplace bound to the current manufacturer ecosystem. But then I mentioned before that FITMAN CAM supports the federation of platforms. So what we can also do is to run searches in the marketplace which span several different ecosystems. So it means that if we do not find the service we are searching for in our ecosystem, we can also look into other ecosystems, of course, which belong to the same federation. From the technology point of view, FITMAN CAM, as I said, is entirely web-based. You have no software to install locally on your workstation. And one single instance can support very large organizations, even virtual organizations, of course. It means that you can, if you want, because this is optional, you can integrate several different corporate user credential databases. For example, you might have in your company, you might have an LDAP or an Active Directory system. You don't need to copy the user credentials inside the FITMAN CAM system, you simply connect your corporate user database with the system, and the same can be done by all the other enterprises which are part of the same ecosystem. So basically we reach a really distributed user database. Of course, you have to follow some models to work with user roles, so that you can assign the proper roles for the FITMAN CAM platform to deal with the authorization problem. I mean that you might want to authorize your users to do different things in the platform. You can do that using your roles. You don't have to do that on the platform. You can assign your roles as you do normally in LDAP or Active Directory. So as I mentioned before, we can create even a federated ecosystem. It means that we can also have multiple FITMAN CAM instances. Then at a lower level, the technologies that are used are open source components, LifeRay, for example, which is the web portal, Sesame, which is the asset repository, MySQL, which is of course the relational database. We also leverage some fireware generic enablers, and specifically we are talking about the marketplace and the repository. Both of them are open source, by the way. And on top of that, engineering has developed some specific modules to deal with asset management and assets as a service management, which I will shortly demonstrate live. And finally, we are also exposing some APIs. So it means that besides the web user interface that I will demonstrate now, you can also integrate applications with the platform by using APIs. You have more than one layer of API that you can choose from. You can integrate at the lowest level, for example, by using the Sesame API. It means that you can have access, direct access to the underlying ontology, to the knowledge base, using the Sparkle query language, which is an SQL-like language to query ontologies. And you can also have a higher level integration by using a proprietary API for interacting with the asset as a service database or with the marketplace. All this runs on any system which is Java enabled, so you can install on Windows Server, on Linux, even on Mac. This is a very high-level architectural overview. I understand that this is not very clear right now, because maybe before you have seen the demo, it is not clear what we mean for standard class, custom class, but I will briefly introduce this. It means that we provide a base ontology which is made of a set of base classes, which you see at the bottom level of this diagram, and a set of standard properties, and all this is system defined. It means that you cannot change that. It is let's say a framework on which you can build your custom classes. And then when you create your custom classes, you can also create custom properties, and then from there you can describe assets using custom classes and custom properties. Once you have defined your custom classes and assets and asset model, you have your reference ontology. So it means that from there you can build, and this is the green layer on top, the asset as a service layer, and also you can compose several assets as a service into a composite asset as a service. All of this is then published in the marketplace that you see on the right side. From a more concrete point of view, this specific enabler will be provided as a virtual machine image to anyone who wishes to have a try at it. We will provide two virtual image formats so that you can choose the best for your environment. We will support VirtualBox, which in turn supports Linux, Windows, and macOS as a host system. And we can also support KVM, which is a good thing for any cloud deployment scenario, because KVM is a standard format in Linux. It is supported natively by OpenStack. So for example, this is the format of choice if you wish to deploy on a FileWare cloud like the FileWare Testbed, for example, or FileLab. We are also thinking of providing a single shared instance as a service so that you can experiment with that, but this is still to be decided. We have no actual plan for this. It is an option. Lastly, about terms and conditions, basically this is all open source software. Several tools have different open source licenses, but the Apache 2.0 license applies globally at the specific enabler level. That said, within FITMAN, we will provide free support to anyone who wishes to use this specific enabler until the end of the FI-PPP program. That said, I think that we can start the demo. Before I would ask you if you have any questions before we start. Okay, no questions, so we can start the demo right away. So before we start the demo, I wish to show you how a tool like Protégé, which is a very common development environment for ontology, how Protégé looks like. I mentioned before that working with ontologies is a daunting task for non-IT people. So this is, for example, the ontology, the reference ontology that we are currently using in the demo, how it looks like when loaded in Protégé. I can assure you that even myself, and I have been working on that for some time, still have some difficulties in exploiting all the features of this tool, which is a very, very complete tool. But as we noticed, most of the features of tools like that are really of no use in the scenario that we are targeting. Instead, Again, I seem to have some problems. This is the demo effect. So if if you don't mind, I will restart the browser session because it seems that it timed out. Okay. Fine. This is how the same ontology looks like in this tool. Here on the left-hand side, you see the tree, the hierarchical tree of asset classes. And when I select one specific class, what I see here in the main area is the list of assets belonging to this class. So in this case, we have weaving machine. This demo is done using demo data, not real data, but it is realistic data from an industrial partner of another research project, which is part of the textile manufacturing domain. So we are talking about weaving, knitting, sewing, and this kind of stuff. Here we have weaving machines, and let's look, for example, at the first asset in the list. I go in the detail page, and what I see here is a list of properties. Properties are simply name-value pair. So if I want to add a new property, I simply choose from a very complete list of existing properties which are part of the reference ontology. Of course, each domain will have its own, and if I want, I can even add new ones. And basically, it is a matter of assigning a value, which might be a string or a numeric value and anything. So it is that simple. But then another useful feature of this tool is that once I have defined an asset, I can use it as a model. So for example, here I have a model, which is the first line, and then I have a certain number of instances which are derived from this model by cloning it. So, for example, I want to create a new asset. I'm not going to modify the ontology right now, so just to show you how it is simple, I give a unique name. I can select an owner, which is one of the enterprises in the ecosystem, and then save it. And the result is basically a clone of the model, but with different values in the properties as I wish to set. Then, once I have created my assets, I have described some, in this case we are talking about tangible assets, so I am describing something concrete which exists in real life. So all these properties are, in this case, are properties of a weaving machine. I have an ID, I have some values which of course make sense for a weaving machine of this kind. But then I can do the same for intangible assets and describe, for example, a kind of knowledge. Anyway, once I have described the asset, then I can expose it as a service. Let's have a look at one asset which I know is exposed as a service, this one. You see I have some tabs. I have a services tab. Here I see the list of services in which this asset is taking part. We have two of them. One is a local service and one is a public service. The difference is that The local service is the virtualization of the offering of this specific asset, while the public service is a composition of several assets into a composite service. We will see that later. In the meantime, I will just show you how I can navigate from here directly into the definition of the asset as a service. This is the local service. So let's return at the asset repository. So do you have any questions by now, or we can proceed to the asset as a service part? Okay, no questions. Let's move to the assets as a service. So here I can see all the assets as a service which are have been created and stored in the database. We have 3 local services and 1 public composite service. The local service you have already seen before when I navigated directly from the assets. Let's look at the composite one. The composite service is, as you see, a composition of local services. If I want to create a new public service, let's make an example. I can select an owner, but then the real point is to select those local services which are part of the public service. After I have created this new service, it is still not published in the marketplace. In fact, if I return to the previous screen, I see that it is not published. So what I want to do is publish it. And this is where the linked USDL layer comes into life. I have to select one template of linked USDL from a list. This is another, let's say, trick to simplify things, because dealing with linked USDL might be again a daunting task. So what we have done is avoiding things like USDL editors, which we have seen in practice that business users are not capable of using. And so we rely on a library of templates, which is a custom library of templates. You can add your own. And we have 2 here. It means that you provide a standard USDL file with some variables inside. And then when you have selected which template you want to use, the next step is this. We create a form where each fields correspond to one of the variable of the template. So you fill in what you want to fill. Of course, this is about pricing, availability. We are not going through this now. Finally, when we publish, we are creating an entry in the marketplace, and we are also filling this linked USDL file and storing it on a repository. And this is basically all. And now it's really time for questions and answers. It's your last chance.
Mauro, can you hear me?
Yes, sure.
Okay. I have a couple of questions regarding the last part.
Sure.
So the creation of the public service made from a composition of local services. So I've seen two things. One is that when you create the service, you actually select the user.
No, the owner, you mean?
Yes, the owner.
That is optional. That is optional. You might create even ownerless services, which basically mean that if you have one ecosystem, those are at the ecosystem level, so they are owned by the ecosystem.
Yes, but what I mean is that when you see the list of local services, actually are the services of the ecosystem. So export
all of them. Let's make an example. Let's make an example.
Owned by all the owners.
All the owners. Yes, exactly. All the owners, because the reasoning is this, that you might want to create a service with a collaboration of enterprises. So you have several enterprises, each one is providing one part of your global service, and this part of a global service is represented by a local service.
Okay. And okay, good. And then another question related again the creation of I mean the publication of the service. It appears after you selected a template, it appears a form, and there was two entries in the form that were valid from and valid to.
Yes, that it depends on your template. It is not fixed, so you can decide whatever your scenario is, which are the relevant fields for you. And you can have multiple scenarios, and you can create one template for each of these.
Okay. And one other question. What about the offering and the actual economic transactions? Okay.
No, that's not in the scope.
This is done by another component. This is actually it's the PP40A that takes care of all the transaction of make an offer, agree with the offer, make an order.
Well, that is really out of the scope of this specific enabler. I know what you're talking about because I am familiar with that software. It's not related with this. I mean, yes, you can even integrate them if you want, because the production planning, which is the PP for T, the production planning component actually is using the Sesame APIs to access the tangible assets repository in this case, and extract what is needed for it, but the integration happens at the lowest level.
Okay.
So it means, excuse me, it means from a practical point of view that if you want to deal with the offering, the commercial offering of the service with the PP4T, it is up to it. I mean, they compose the service by scheduling the availability of resources, and they do this by accessing the asset repository, but then when they have to publish this offering on the marketplace, they are on their own. They do that directly. They interact with the marketplace directly. So the marketplace is a separate component, and in fact it is a fireware generic enabler.
Okay, so you use the marketplace to publish the offerings.
Yes.
Okay. Okay, even if we haven't seen this part in the presentation, I guess.
Yes,
Or
because we
have I missed something?
no. You're right. We don't have a front end to the marketplace because we are using the marketplace as it comes from Fireware. So currently we don't have a front end for that. You might roll your own, as they say, or you might use existing front ends. You know that there is a front end for that which has been developed in the scope of the MSC project, for example. And that front end, by the way, supports the federated search. So you can run the same search across several instances of the marketplace. But we are not providing any front end to the marketplace as part of FITMAN CAM.
Okay. And last question, is the ontology available? So can we point to the URL of the ontology?
I can provide it as an RDF file if you want.
Yes.
Yes, sure.
Would be nice. Okay. Okay, good.
By the way, if you are interested in the technical details of the ontology, how to create an ontology which is suitable for use in this tool, we can discuss between us on that. I mean, it's not now the right place to do it, but I can give you a lot of hints on how to do that, because you have to do something and avoid doing something else. Yes. I mean, you can load an ontology exactly how it comes out from Protégé, but the result is not very manageable in this tool. So you have to adopt some standards, let's say.
Okay, because we are building an ontology for our trial, and actually there are, of course, there are a lot of overlaps with what you have done. We have just did it just to model the domain. And but of course your ontology, it's complete, and so I would like to make a comparison and between the two. Okay.
Fine.
Okay. Because actually our domain actually mostly overlap your domain.
Yes, I know. You're talking about Piacenza.
Yes, Piacenza. So it's textile clothing. So it's basically the same.
Yes, I think that.
But actually, yes. But actually, there is a difference in the. I guess there is a difference in the business. Actually, in the business use case, because actually, what you have seen till now is that from Piacenza we do not get data that goes to the single machine, to the single, for example, weaving machine, but they talk about capability. Yeah. Capability in terms of capability of weaving for the next week. Yes. But they are probably they are not able to already allocate the specific weaving machine with 1 week in advance.
No, I'm very aware of this. I know that it is very different, and I think that in Piacenza you are more interested in intangibles better than tangibles, because capabilities are intangibles. You are describing something which is not concrete. You have not the corresponding hardware in real life. You have something. I mean, you have a sort of cloud, let's say, to which this capability apply. So you have, of course, a different ontology. But that said, you model as you wish. This tool is not constraining you to adopt any specific data model at all. You are free. You just have to follow some conventions while you actually build your ontology, but the concepts you put inside are completely, it is a black box for the tool.
Okay. Okay. Thank you for your help and the answer. Right.
Thank you for the questions, because you were the only one. So, are there any other questions? Oh, I see. Okay. I see questions in the chat. Yes, I am going to share the slides, and I am also going to publish the recording of this session. So you will have all the material online soon. Okay, so no other questions, it seems. I think that we can close it here. Thank you very much for attending.
Okay. Thanks to you, Mauro.
Bye then.
Okay. Merry Christmas.
Merry Christmas to you.
Bye-bye.
Bye-bye. Bye-bye.